Welcome to this module on the EIGRP packet header. So what are we going to be taking a look at as we delve into this module? Well, we're going to be looking specifically at sort of a deep dive conversation here with respect to the EIGRP packet header. So if we were to take a look at RFC 7868, you can see that this is the header, right? And it shows us the different fields that we're going to see in a header. We're also going to see something a little more instructive with respect to the values that you would see in this field when we take a look at our Wireshark packet capture. So I'm going to use a program here called ScreenFloat, and I'm going to go ahead and grab a shot of this. And so what's going to happen is as soon as I highlight that, I now have sort of a movable copy, and this will always remain on top here. I could save it if I wanted to, but again, we're going to be using this throughout this lecture. So this is the EIGRP packet header, and just like OSPF has a packet header, so does EIGRP. And now let's go ahead, let's walk through each of the fields here. I'm going to slide this over to the extreme side there. And so what are the fields that we're looking at inside the EIGRP packet header, and specifically what does it communicate? So we've got the version field, the opcode field. If I were to pull this over here, you can see these are all going to match up, right? So here's the header version. The current version is 2.0. Here's the opcode field. We'll take a look at the different opcode values, whether it's a hello packet with an opcode of 5 or it's an update packet. We've got the checksum value, making sure that it is valid. We've got flags, and we'll dig into these flags. We've got the conditional receive flag. There's a restart flag, end of table flag, and the init flag. Sorry, the most important one is probably the init flag. And then the init flag. And then the sequence number, right? We talked about this in the previous core concepts module. We've got our sequence number, right? Reliable packets like an update or a query or a reply, are going to be sent with a sequence number, right? We've got the acknowledgement number. Remember that the acknowledgement packet is going to have a value in this field, right? It's basically a hello packet with some value in this acknowledgement field here, the acknowledgement number field of the EIGRP packet header that is going to mirror the packet that it's acknowledging, whatever the sequence number from the packet it's acknowledging was. And then we've got the virtual router ID, and then the all-important AS number, the autonomous system number, right? And the reason that this is important is, remember that the adjacency between two EIGRP peers is not going to form if they don't have the same autonomous system number. Now, this isn't to say that I can't get routing information out of one autonomous system into another. That would be a case where we're going to be doing redistribution. But we're talking about standing peers up, right? Adjacencies between two EIGRP routers, and so therefore the autonomous system number must match. This is very different from OSPF. When we talk about OSPF and the process ID number, that is locally significant up until we start to talk about MPLS L3 VPNs with OSPF, right? But for OSPF, just normal neighbor adjacencies, that process ID is locally significant. You can think of the autonomous system number as kind of like the OSPF area number, so to speak, right? Where everything in the same area or in the same autonomous system with respect to EIGRP is going to be looked at as an internal EIGRP route. Whereas anything from outside of, in the case of OSPF, outside the area or outside the AS with the EIGRP, it's not going to be considered internal to the area, right? Because with OSPF, it's intra area, right? It's going to be coming from another area, and we would kind of, again, kind of a loose analogy here, but trying to drive home the point that that AS number is going to be critical. So let me go ahead and kind of move this to the side, and let's transition here. So those are the fields in the header, right? Now, again, version 2 is the current version. We're going to see that. Here's the opcode values, right? So if it's an update packet, and again, kind of talk about it in terms of like the payload, right? So here's the header, and then after the header, we're going to have the payload, and the payload of EIGRP packets are expressed in terms of type, length value, what we call triplets. And when we get into each of the packets, we're starting with the hello packet. We're going to kind of be working backwards numerically, but working forwards from a order of operations perspective. So, and I've always wondered why the hello packet ended up with the opcode of 5 and not an opcode of 1. So, because the hello packet is the first packet that's going to be sent when we're trying to stand up an adjacency. So, again, this is kind of the header, and then behind this, we're going to have our payload. So if it was a hello packet, we would have the type, length, and then the values associated with that hello packet. But again, these opcodes right here in this, I guess we would call these the high order, second 8 high order bits here that are going to follow the header version. And then, of course, the checksum is simply just that. I mean, the checksum is really nothing more than the field that is making sure that the packet is valid, right? That it's not an invalid packet. Yeah, it's just making sure that the contents of the packet are valid, right? Okay, so let's move on here, and we've got the flags. I kind of mentioned the flags. We've got the conditional receive flag, the init flag, the restart flag, and the end of table flag. And so what these flags are all about, the init flag, this is going to be, now this is important, the init flag is set in the very, very first update message when neighbors are forming an adjacency. And the reason that the init flag, remember we talked about partial and bounded, right? So here's where it's not partial. When that init flag is, set in the initial update packet, that initial update packet with an init bit set is indicating, is telling the neighbor, hey, give me all of your routes. And this is how EIGRP, when the adjacency is first stood up, is able to transition to a partial update paradigm, right? Because if I get the whole routing table initially, then all you need to do is just send me the updates. The conditional receive flag, we'll talk about this. It relates to when we start to look at the sequence type length value with hello packets. We've got the restart flag. And this is if a neighbor is restarting, you'll typically see the restart flag set. And then we've got the end of table. And what this means is, hey, this is it. We've finished, the neighbors have finished the startup process between the two. We've sent all the updates, and so we are at the end of the table, right? I've got all the updates. We're at the end of the table. So we'll see that as well. So again, those are the flags that can be set. You'll actually see the values. We've got our sequence number. We've talked about the acknowledgement number, right? Remember, sequence number is set in reliable packets, because when that sequence number is set, you're basically saying, hey, when you acknowledge what I just sent you, give me my sequence number back in the acknowledgement packet, which, remember, that acknowledgement packet is nothing more than a hello packet that has a non-zero value. Specifically, the value will match the sequence number in whatever the reliable packet was in that field, right? In that acknowledgement number field. We've got a virtual router ID, and this is a little outside of our scope, so we'll just leave it at that. Know that the virtual router ID is there. And then the autonomous system number, right? Again, we talked about the AS number and why the AS number is so important. So again, if we were to go to Wireshark, let's see what this looks like in a little more detailed fashion. And it looks like, let me get Wireshark up here. I apologize there. It looks like it was down. So we're going to leave this here, and let me stretch this up a bit because we can see just about everything we need to. And so we'll leave it right there, put it on top of the IPv6 packet that we're looking at here. So when we talk about the header information, let me drop down. There's our flags, right? We talked about those flags fields. Now, that is where the packet header stops, right? The autonomous system number in the EIGRP packet is the last bit of information before we get, and it's interesting, Packet Tracer calls it parameters, but it's really the type, length, and value triplets, right? The payload. So the analogy that I like to use when thinking of the parameters and the payload information, right, these TLV values, is that this is layers 5 through 7 in the OSI model, right? And again, that's an analogy. I'm just basically trying to draw sort of a similarity. Like we look at, you know, you work your way up to the transport layer, and then you've got application, presentation, session, right? Application, presentation, and session. And the PDU for those 3 layers is data, right? Those are the data that we're looking at. And this is kind of the same thing, right? This is my data payload below the header. But here's the version. Current version is 2. The hello packet, the opcode is a 5. Our checksum, right? Does everything check out? It does. We look at our flags value, right? Huge, huge hexadecimal value here, or could be possibly. But again, the init bit, not set. Our conditional receive, again, these are just hello packets here, nothing special. Restart, not set. End of table, not set, because again, they all have 0 as their value. When we take a look at that initial update packet, you're going to see that this is going to change to a 1, right? Indicating that the init bit is set in that update packet, instructing the neighbor, hey, send me all of your routing information. I need it all. It's a hello packet. The sequence is 0. It's unreliable. And is it an acknowledgement packet? No. Right? And again, remember, if it's a non-zero value, if it's a hello packet and there is a non-zero value here, it means it's an acknowledgement, right? If the sequence, again, the sequence number is 0 because it is unreliable. We're not asking for anybody to acknowledge the hello that we're sending. Here's our virtual router ID for the address family. Again, we will come back to this, but we'll talk about that later. And then our autonomous system number. So if you were to be given this output here and asked, is this an acknowledgement packet? What would your answer be? Yeah, no, because we don't have a non-zero value here. If you were given the command router, or actually since we're talking IPv6, or I need to be careful, IPv6 router, EIGRP, and then what number was used in that field for this output? Exactly, the autonomous system number, the AS number of 1, right? So again, this is our header. You can see here, there's that layer 2 address. Here's the layer 3 multicast address for IPv6. That's that layer 2 IPv6 multicast address. And then you get the header. All right, well, this is going to wrap up our conversation on the EIGRP header. The first opcode we're going to be taking a look at, or the first EIGRP packet type, is going to be type 5. We're going to be looking at the hello packet. And so thank you so much for watching, and I hope to see you in the next module. Whoops, clear that off there. I hope to see you in the next module. Thanks for watching.